So in the recent videos we've been looking at, we've had these detectors in the array, and we were measuring the EDEP in them, and we've seen how to overload functions depending on how many inputs we give them. But let's say you're doing a study and you're shooting some radiation source from the right, and you want to see how the radiation field varies or the response of the detector in this field. And so if we just open our detector instruction shortly, but let's say we want to move it in all these different positions, let's say like 100 positions, then it would be an absolute pain if we had to move the detector in these detectors in the detector construction and compile it, then run at that depth time and time. So it's much more convenient if we can just give the program the depth we want to run at, and then have it do everything automatically for us. Whenever there's something repetitive, replace it with automation. So if we open a detect construction, then you'll remember we had our setup like this, where we had the depth fixed just in the center of the world. But let's say we want to change this to some other position willy-nilly. So let's go to our main. Well, actually, let's open our header first, of our detect instruction. And so we've got a few options we can do. We could make a function like specifically for like get depth, and we could input the get the position and then change a variable, or we could just, like we did with stepping action, we could just overload the function. So we'll see how I'm feeling, but let's just overload the function for now. So we're gonna give this function Geant4 double as its input, and while we're here, let's make a variable called detector depth, and we're just making sure we haven't already defined detector depth. All right, good. So in our current constructor, which does nothing, we're just going to have detector depth set to 0 millimeters by default. And while we're playing with this, let's move it into here. So just place that with detector depth, and let's have some output here for safety. Detector is being placed at detector depth in millimeters. And let's add our other constructor, which would take the input and actually that probably won't like me doing this, will it? So let's just see if that compiles. I'm guessing he'll be upset with me. So 60F expected constructed destructive type conversion for what is that 67 detector depth? Okay, because whoops, and so we'll do it the simpler way and just have our G4 double and then have our trend depth or like transition depth. So let's just have our detector depth is equal to our trend depth. So this function, instead of assigning the value of detector depth directly, we're using this transition value and then assigning the value of detector depth. So let's see, that's happier with us. All right, good. So if we ran it now, edep run electron, just less it for the detector. So just make sure that detector is being placed at 0. Good. So what I'm going to do eventually is I want to run this program with the macro, and I want to just be able to specify what depth I want the detector to be placed at. So this is very handy, like when you're doing studies where you just want response or measurements at many depths, and probably in a later video I'll show you how to use a for loop with your PBS, and then you can just submit it. Just making sure. Okay, color's still disabled. So let's go to our main now. So where is our detector construction input? So gonna get a little messy. So when we're doing something like this, I don't know if you remember, but in one of the early videos when I was going through the main with the argument counts, I was saying how whenever you run a program, all these separate arguments you give after the program name are counted as separate arguments, and there's an argument count. So actually, let's go to that. So up here, you've got your argument count and the argument values as the input. So it takes in the argument values and the counts. So let's just below the seed, and it's already being used here for the visualization. So let's just go G4 C out the number of inputs / arguments is equal to arg count. So if we run this now, compiling, so number of inputs / arguments is currently 2. So remember, this is 1, this is 2, so one macro will make the number of arguments 2. So let's try to be fancy, and let's say, where's our detector construction? So let's say and we'll just define that like that. So we're going to tell the program that depending on how many argument counts, we're going to execute a certain detector constructor. So if our argument count is equal to 2, or actually let's go less than 3, then we want to just execute this default program. Default constructor with no input. So we'll just go like so. And otherwise, we want to execute the overloaded the one with the input. So that will be so this argument value, this is an array which holds all the values, and I keep losing where it is, argument value, and we want to access the third one, since when we run it like this is 2 arguments, and this will be argument value 0 in the array, and this will be argument value 1. So when we have a depth, we'll have argument 2. And our function in our detect instruction function, it's expecting a double. So, and what these are stored as when you input them to the main is character arrays. So we need to convert this into a float or a double. So I think the memories for AT floats. Oh, okay. I was expecting I had to look that up, but it seems to be okay. So I'm guessing there'll be an error here. Oh, okay. Maybe we'll be unlucky and have a runtime error. So we're just going to run it exact same. Oh, let's do some outputs to the screen. So no depth not given using default. Whoops. Oh. And let's just go main so we know where it's coming from. So main. Depth not given, depth given. And let's go equals blah. And then we'll just output the argument value directly as a text. So let's compile that again. And let's just run it again, but let's say we want to have it at depth 100. So our phantom's 300 millimeters. So we're just using the default Geant4 system of units, not system of units, the coordinate system of that phantom. So 100 would be 50 millimeters from the wall, the positive side. So let's just run that, see if it actually works. So main depth given using, I didn't change the default, but it's good. So let's go to the detect construction, see if it's changed the depth. Detector is placed at 100. So it's looking good. Let's just go to the end and let's change, that's promising. So this output here should hopefully, so let's just print that to the screen. Detector edepth 92. And let's output this one. Let's do this one. I just can't remember if those were which, because I did a bit of cancelling, so it might not contain anything meaningful. So the values are very close to one another. So let's just open a detect instruction quickly. Just visualize. And one drawback of using this this system of changing the inputs, like the argument values into the main, is that it sort of generally breaks your main setup of the visualization because it's expecting certain argument values. So without them, you can't just visualize the depth that you're being placed at without making a few changes to how it functions. But so I was just seeing which direction 100 was, so it'd be this way. So let's just quickly try with minus 100. So because from memory, I think we're shooting the beam at minus 5 centimeters or something. Where are we shooting? Yeah, minus 5 centimeters in the Z. So if we move our detectors to minus 100. Oh wait, these are millimeters. Oh, okay, wait. No, that should be okay. So if we go to minus 100, and just thinking, no, that's okay. I was thinking if we'd get overlaps, because I couldn't remember how big our detectors were, but I think they were 5 centimeters in total thick. But now we've got barely anything, so we're probably just getting a few backscattered or scattered electrons and photons generated, blah, blah, blah. So that seems much more reasonable. I forgot that we're shooting at 150 MeV or something. I thought we were just doing a 6 MeV electron. So that seems to make sense. So that's how you can change the input or change overload the function again and move the detector, and instead of having to recompile the program, you can just change the input as you run it, and then you get the different outputs. So in the next video, I'll probably just quickly show you for completeness how you'd change the file name to also take the detect instruction, just repetition of what you've already seen, but just for completeness, we'll do it